Welcome friends. In today's video, we will be working on project number 12 and we will be predicting the sales of Big Mart using XGB regression. For that, we will be using Big Mart sales dataset provided by Kaggle. In this, you can download the dataset. You can download train.csv. I will be providing the link in the description below. Now looking at this data column, you can see we have total of 12 columns with 8523 rows. It has some missing values as well, like outlet size has some missing values. Okay, now coming back to our project, we will be using XGBRegressor. So it is a regression technique. First we will be importing all the libraries. Import numpy as empty, import pandas as pd, import matplot library dot from sklearn dot preprocessing import label encoder and then from sklearn dot model selection. I think I need train test. Let's type it. Model selection import train test split, then from XGBoost import XGBRegressor, from sklearn import matrix. That's all. Okay, so what is numpy? Numpy is used for array manipulation, as it is more efficient than normal arrays. Then we have pandas, that is used to convert our data set into pandas data structure. Then we have matplot and seaborn data used to draw graphs and for visual analysis. Then we have label encoder, that is used to convert our text data into numeric form. Then we have train test split, that is used to split our data into training and test data. Then we have XGBRegressor, that is used to train our model. This is the algorithm. Then we have matrices, that is used to find the accuracy of our model. Now first we will do data collection. It's a Big Mart data is equals to read CSV pd.read CSV, and we have Big Mart data. Dot CSV. Let's print first 5 rows. Big Mart data dot head. So it has printed all the 5 rows. We can see we have some text data like in item identifier, in item fat content, in item type, So many of them are have text data, and some of the values are also missing. Okay, so let's analyze the data first. We will print number of rows and column. So we have total of 8523 rows with 12 columns. Now we will print some basic information like what are the data types, how many values are missing, like that. So we can see data types are written on the dtime column, and some values are also missing like item weights. Some item weights are missing, outlet size is also missing. Rest have the all the values. Okay, we can also see that many of the columns have the data type of object, or you can say text. So what we can do, we can write a note here. These are the categorical features. What are these? Item identifier, then we have item weight, item weight is not, sorry, item fat content. Item fat content. Then we have item type, then we have outlet identifier, then we have outlet location type, and then we have item outlet size. Outlet sales. Yeah. So these all are the categorical columns. So we have already checked for the missing values. Just to be just to show in a more clear way, we can print the missing values like big metadata dot is null. So it will give how many rows, how many missing values are there in a column dot sum. So as we analyzed previously, there were some missing values here, but how many of them were missing? So there are 1463 missing values in item weight column and 2410 missing values in outlet size. Now we will handle the missing values. We will use two concepts. The first one is the mean, the second one is the mode. So what is mean? Mean is the average value. So whatever the average is of all the weights, we will put the average in the missing column, and we will put the mode in the outlet size. Okay, the first we will find what is the mean. Mean is equals to big Mart data item weight dot mean. So it will find the mean of the item weight column. Now what we can do, we can print the mean. mean. So it will print the mean. So print is the mean is coming out to be 12.85. Now what we can do, we can fill the missing all the missing values with the mean. So big Mart data dot item weight dot fill NA with what, with mean, and in place is equal to true. So it is in place. So what we did, we fill all the missing values with the mean, and in place true means we are updating the original data set. If we will not use this, the original data set will not be changed or will not be update. Okay. Now we will again check for the missing values. So how can we do it? Big Mart data dot is null dot sum. Okay, so it's a function. So as we can see, we don't have any missing values in the item weight column. Now we will be replacing the missing values in outlet size column with mode. And then we will find the what is the mode. Big Mart data dot pivot table column aggregate function. Yeah, so it will find the mode. So what we are doing, we are finding all the mode values from the outlet type column from the outlet size, and we are it is a you can say lambda function. For every x it is checking, for every value that is represented as x, for every value it is checking for the mode, the most repeated word. Now we will print mode. So it is giving as modes. Grocery store has the highest repeating word as small, and likewise all. Okay, so what we can do, so it finds the mode from, like, for outlet type grocery store the mode is small, and for grocery outlet type supermarket type 1 the mode is small, and likewise for other columns as well. Now what we can do, we have to find the missing values. Missing values equals to big Mart data outlet size is null. Nice. Then we'll print missing values. We can see the fourth column is missing, and 851 and column is also missing. We can check also here in this table the fourth column is missing and then not a number. Then we can replace all the missing values with the mode. Okay, so big Mart data dot location missing values outlet size big Mart data, apply lambda x of x. So we replace all the missing values with the mode for their respective outlet type. Okay, so if a column has outlet type of grocery store, so we will replace it with the small. If outlet type has a has a value supermarket type 3, so missing value will be replaced with the medium. Likewise it goes with the other records as well. So what we can do, we can check for missing values if all the values are there or not. So we can use the same is null is some method. So big mart data is null dot sum. Okay, so as we can see, we don't have any missing values now. Now what we can do, we can virtually no we can visualize our data. So how can we do it? We need to set our data frame, then we will visualize the data for the weight, item weight, distribution. SNS we will plot a density plot graph, this plot, and plt.show. Okay, so as we can see, items with weight around 12 has the highest density. Okay, so same goes with the item visibility. In place of weight we will write visibility. So we can see the items with visibility around 0.0 to 0. Around 0.8 has the highest density as compared to other one. Now what we can do, we can analyze the establishment year of the outlets. So let's write a comment, outlet establishment year, column analysis, sns dot count plot, data is big data. Okay, so we can see the outlets which were established in 1885 has the highest amount of count. That means there are around more than 1400 outlets that were established in 1885, and all the like in 1887, 97, for every year the count remains same, around 900. Okay, now we can analyze the data for the categorical features. So first one is the item fat content, sns dot count plot, item fat big data. So we can see that items with low fat has the highest number of count, more than 5000, and items with regular fat has a count of around 3000. Okay, now we can do for the outlet size as well. Outlet size column plt dot figure. We can do it more. These are the dimensions. like 30 by 6. So it gives us the count for the medium size outlet. We have a count of nearly 3000, and for the outlet size small we have a count of around 5000. Okay, so there are more small outlet size which are there, nearly 5000. Okay, so now we will do data pre-processing. You can try out for the other categorical features as well. So first let's analyze our data. So I have printed the first 5 rows. Now I have to find out the fat content. We have low fat, regular fat, then low fat, regular fat. That how many uh, type of content are there in this column. So for that, what I can do is big mart data dot value count. It will give me. So there are more than 5000, like 5089 records of low fat, 2889 of regular. We can also check here that there were more than 5000. Yes, so our data also says that there are more than 5000 of low fat. So there are total number of 5, uh, you can say 5 values are there. Okay, so we can do what we can do, as we have low fat is 5089. LF also means low fat, regular means reg, and regular fat, they also are same, and low fat and low fat, they're also same. So what we can do, we can replace low fat, LF, low fat all with LF, and same goes with the reg, regular with the regular. Okay, so just so that our data became more accurate and more reliable. My data dot replace so we have replaced low fat with low fat, LF with low fat, regular with low fat. Now if I just do again, we would have only 2 values, regular and low fat. Yeah, low fat and regular. Now that is good. Now what we can do, we will use label encoding. We will convert all our textual data into numerical form. So encoder is equals to label encoder. We initialized our object, and then big mart data item identifier. First we have item identifier, yeah, then big my data item fat content, item fat content, item fat content. Then big mart data item type, big mart data outlet identifier, outlet location. We have outlet size as well, outlet type and outlet size. Big mart data outlet size. So let's run it. After running it, we can just print our data dot head So we can see that all our data has been transformed or encoded to numerical form. Identifiers converted to numerical form. All the values are converted to numerical form. So now our model can easily analyze our data. Now what we will do, we will split our data. Split data into target and features. Target is the output column. Here the target is the total amount of sales. So we dropped item outlet sales, that is the target column, and all the other columns are there in the X, and Y has a target, or you can see the output column. We can print X and Y just to check. So X has all the columns except the target, and Y has the target column. Now we will split our data into training and test data. X train test, Y train, Y test. Just a minute. Train test data X and Y random size to. So we splitted our data. Let's print the rows and columns. X dot shape, X train dot shape, X test dot shape. We can see initially we have 8,523 rows. After splitting into training and test, in train data set, in data we have 6,818 rows in the extent variable, and in test we have 1705 rows. Now we will do model training using XGBoost regressor. So regressor is equals to XGBRegressor. So our model has initialized. Now regressor dot fit train so our model has been trained successfully. Now we will do prediction. So prediction on train data is equals to regressor dot predict X train then R square error score is equals to R to the score Y training prediction. Yeah, that's correct. So our model is 87% correct. So what I did, first I train our model using X-train and Y-train. X-train has all the columns except the target, and Y has a target, so it will map all the columns accordingly. Then it will predict on the training data. It will on the training data that we used to train. So now the actual tests come. Prediction on test data prediction is equals to regressor dot predict. So we have the prediction. Now we will print the accuracy score using R square error. Test, you can just say this test error score. It will show our model is 50% accurate. So that's all for now. If you have any query regarding this project, you can comment me, and don't forget to like and subscribe. Thank you.